Hello, everyone. I'm Andy from ThinkMo. I am currently teaching CCIE courses. From today on, I'm going to share with you CCNA, CCNP, CCIE related technologies. Our topic today is IS-IS improve the SPF calculation method and its intelligent timer problem. In terms of what we're talking about, this includes faster ISP generation times. The LSP flooding time is accelerated. All of these are part of the fast IS-IS convergence. Today we're going to talk about it. The calculation method of SPF. First of all, what is SPF? It's called the shortest path first. Shortest path first. It is derived from the link state routing protocol. The value includes OSPF and IS-IS. They all use this algorithm. In the early days, everybody uses SPF. It's not called SPF anymore. It's an improved ISPF. It's called the enhanced SPF algorithm. In the early days, it's doing SPF calculations. If one of the devices on the network fails, or add a new device, the whole OSPF network, or every single one of the entire IS-IS network, routers calculate SPF. Shortest path is easy. It is rooted in itself. And then I'm going to go in all directions. Figure out a shortest path. Let's say this is the first one. This is the second one. This is radio 3. This is radio 4. First metropolitan computing. Shortest path to network X. That's the algorithm for SPF. Tree algorithm. What's the downside of the early algorithm? Once an additional device is connected, every router has to be recalculated. But it's actually increasing from here. We're going to divide it from here. The top 4 devices. Or add it to this device. These 3 devices don't have much to do with it. The router added to this router. On the other 3 routes, there's no need to do it yourself. That's pretty much what it looks like. This is the amount of resources that would normally be consumed by only one device. Then the entire OSPF network is recalculated. It's especially wasteful. So ISPF is if you add a node. The device takes the results of the calculation, send it to other devices. ISPF is called incremental route calculation. Only the changing part at a time. Of course, the changing part needs to be noted. Not just increase but decrease. Only a portion of the topology that changes is computed, instead of calculating the entire topology. The first time I did it, it must be every device. It's important to know if the path of the whole network is correct. So I'm just computing all the nodes for first time. Only the affected nodes are counted each time. We're also going to talk about PRC here. It's called partial route computing. Let's say this is a tree. These are tree trunks and branches. These branches are the equivalent of connected to a router. It's also called a tree trunk. PRC is for routing information. Isn't this a tree trunk? And then one leaf after another. Trunk at the top. So PRC computes routes. It's the one that's attached to the router. Let's say this is the network of networks. This is what we call the server segment. Or some other device. ISPF is the tree trunk. It's the router connecting the router to router. It's called the trunk. PRC computes routes. That's the leaf. The following network segment is connected. Similar principle. The difference is that one computes routes. One computes the nodes. Here's how to improve SPF. And then there's the timer. It speeds up the SPF calculation time. It's called Smart Timer. So let's look at it in the same picture that we just did. if we want to accelerate convergence. But there's something wrong with its link. It's going to cause turbulence. In that case, the device. It's calculating all the time. So smart timers. The main thing is to control its rapid convergence. The time between it and what we said before. It is to speed up the generation time of LSP. It also has a smart customizer. We can look at it in detail. Of course, timer SPF. You can use this command to set the time. The initialization time is the first time it fires. And then there's the incremental delay. The first is the maximum delay time. Let's say I set it to 10 seconds. Then leave in 10 seconds. Let's say this is 1 and this is 2. And now that this is interrupted, I have to recalculate. Recalculating time is set after 10 seconds. The default is 5 seconds. And then there's the init initialization time. If you set this time as well. The first time max configuration. Second time init. It's called a time of departure. A departure time is a one-off. That's when the first change happens. Let's say I configured 10. That was just 1. The first time if you interrupt. It's running again. This is time for the second time. It's called increasing delay time. Then configure an incremental delay time. The first time if something changes. I might configure this to be 2 seconds. If it changes again. And then you multiply it by 2. If it changes at all. I just keep multiplying by 2. Until the time is reduced to initialization time. That's it for today. If there are any other skills you'd like to learn, feel free to leave a message. Or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.